Hi, and welcome to our lesson about graphs for categorical data. So today we're going to be talking about bar charts and some of their close relatives. To get you started, I'd love to have you take a look at the graph that's shown here. There's so much wrong with it that words can hardly express it, but I'd like you to help me pick out some flaws. One of the big ones is that we don't have a title here. So I'd like to give you a title. This graph is supposed to be showing senior coolness. Okay, this is the senior coolness meter. So with that title, so that now that you know what the graph is supposed to be showing, I want to ask you to stop the video and pick out some other flaws in this graph. Over the years, these are some things that people have mentioned to me. Notice that the bars here are not of uniform width. That senior bar is way wider than any of the others. Also, the spaces in between bars, the gaps here, are not uniform either, and that kind of is deceiving. It makes this graph look a little odd. The scale on the y-axis is not going up in equal steps, and folks, this is a common flaw that graphs have. If you read the scale, it's telling you that juniors should only be a third as cool as seniors, and yet their bar is way more than a third high, right? That scale needs to go up in equal increments. The fonts on the x-axis, it's been pointed out to me that somebody has made the 9th graders really, really small. Right? They get bigger, and then this one totally ununiform. These all have numbers, this has the word. So we want uniformity in graphs. We're not supposed to create a graph that draws unwarranted attention to any one of its bars. This is just no good. Notice too, there's color only on the one bar. If you're going to use color, it should be uniform. Everybody should get a color, not just the seniors. And the last thing, there is no label on the y-axis. It would be hard to label, I guess, unless you were going to say coolness ranking or something like that. So lots and lots and lots of stuff wrong with this graph, but we don't want to have deceptive graphs. Instead, we want to have good graphs. And so I'd like to have you take down some notes about what every good graph should have. A descriptive title and labels. The x and y axis should have labels. The bars and spaces should be equally spaced or uniformly spaced. Colors should be uniform, all the same color, or complementary. That is, we should not make one of them neon orange and the rest pastel. Okay? They should be uniform. The y-axis should have equal steps. That's always true in a bar graph. Okay? So I'd like you to take this totally made up data. Actually, it's not that made up. I collected it from a class in a previous year. I had these pet types listed and asked people to mark whether they had any of this type of pet in their home. And these are the number of homes that had each of the pets. In a bar graph, in this bar graph, the y-axis is going to show frequency. So I'm going to put that label over there right now. I can see that I have to get up to 17 at least. I like my bar graphs to start at 0. It's not always practical, but 0 usually gives us the truest picture. I'm going to make mine go up in steps of 3. So there's 3, 6, 9, 12, 15, and 18 will do it for us. As far as having the bars equally spaced and equal width, there's no rule that says the space has to be the same width as the bar. However, I'm gonna make my spaces be small, and I'm not gonna start right up next to the axis. That's my choice. So there's the bar for dogs, a smaller space, bar for cats, smaller space, bar for hamsters, smaller space, and you're getting the picture. So this first bar is going to be my dog bar, then cats, then hamster, which I'm going to have to really try hard to fit in there. And I'm going to go ahead and draw my first bar, and then I'm going to ask you to pause the video and complete that bar graph, please. We had 15 dogs, or homes that have dogs, which reminds me, I need to have a title. I'm going to call this Pets. Alright, and I'm going to ask you to pause the video and complete that graph, please. Well, here's mine. It's not the most beautiful graph I've ever seen, but it does, I believe, get the idea across. You can tell that more households had cats as pets than any other thing. Let's look at some relatives of the bar graph. The first one that I'd like us to discuss is called a Pareto chart. And ladies and gentlemen, a Pareto chart is a bar chart where the bars go in decreasing order, descending order. So tallest bars are on the left and it goes down from there. This type of graph is used to show the importance of the categories in your bar graph, which ones, you know, have the most weight, if you will. Now in this pet graph, the only thing that we would have to change is the way things are ordered. So instead of starting with dogs, we would start with cats, since there were more of them than anything else. So I'm going to go ahead and draw a couple here. Dogs would come next. And again, you're going in decreasing order. So hamster. And I'm not going to continue this, but I think that you get the idea. We're still measuring frequency here. This is still a graph about pets. It's just that we're showing it from tall to small. So the cat bar would come first, etc. One reason that I would not make this choice for this set of data, that category other really should, all things considered, it should not show up in the middle. That should be an ending category. So if I were going to make a Pareto chart, I might consider sticking that other category down here at the end. I'm not sure that that would be the best choice for this data. A pictograph is something that you might remember from your younger days. Okay? A pictograph uses a duplicated or replicated picture over and over again to represent a frequency. Like you could use one stick man for 10 people or something like that. If we were going to do the pet data that way, we'd probably try and use something like, maybe we'd say doghouse, one doghouse is equal to 5 pets. And then we'd have to be very careful to draw all of our dog houses the same size. For the dog category, we'd need 3 houses. For the cat category, we'd need 3 2/5, so 3.4 houses. This is not probably a graph that we see frequently. However, USA Today newspaper used to use the pictograph quite frequently. It's an easy to interpret graph. The next type of graph that I'd like us to focus on is the pie chart, or circle graph they are called. We are going to create a circle graph today. So I'm going to have you center in or mark the center of your circle. In order for us to do a pie chart, we have to know the percentage of data that falls into each category. I totaled up the frequency here, and we had 57 households represented. So to find the percentage of dog data, we would take, and I'm going to write it up here, 15 divided by 57. Find that percentage. I rounded mine to 3 places, and that was 0.263 or 26.3%. That percent of my circle has to go towards dogs. So now I multiply 0.263 times 360 to come up with a number of degrees. And folks, that came out to about 95 degrees. I rounded to the nearest whole number here. I took my percentages out to 3, multiplied by 360, and rounded to the whole number. And I'm going to ask you to pause the video and compute the rest of these percentages in degrees. Here are my numbers, and I hope they match yours. I'm sure they do. I totaled to make sure that I was at 360, and I found that I was at 361. So that means that we have some rounding error, which makes sense since we had to round off every number here. Okay? We should not be surprised by that. So this won't come out perfect. To begin your pie chart, folks, what most people do is from the center dot draw that line out horizontally, and then it's use your protractor. Right, I have my protractor. I'm going to line up the center dot on the center of my circle, baseline of the protractor right on the edge of the angle, right on that horizontal line, and I need 95 degrees. This is my 0 mark, so I'm using the inside scale. I want to come up to 95 and just make myself a little guide mark there. Alright, I'm going to move my protractor out of the way, and I need a straight line. I'm compulsive about stuff like that, so I'm going to use my line tool and just draw straight up from the center to my mark. That's a 95-degree angle, and that represents the dog category. Now I'm going to, through the magic of TV, put my completed graph up and remind you that you will have a chance to do this in school. Alright, here's my completed graph. I do have a title. I labeled my categories outside since I knew that I would have one where I would have a hard time fitting the word inside. Some people put the percentages in a pie chart. It's totally up to you if that's your choice. Again, we will have a chance. You'll be doing that in school tomorrow. Now the last type of graph that I want to talk about is a line graph today. Line graphs show change over time. So the x-axis in a line graph is always some time unit. I'm going to sketch a little graph that shows the price of a gallon of gas over the 5 weeks in September. So I'm going to move this out of the way so that I have a little bit of room to work. So in my line graph, I'm showing the price of a gallon of gas. That means that my y-axis is money. X-axis shows time. And as I said, I'm going to talk about the weeks in September. So there's the 1st of September, the 8th, and I'm going to go ahead and label the rest of those. The x-axis or the y-axis, probably starting at 0 is not practical. We know gas is never going to get there, but I am going to start at $3, and I'm going to go up in 25-cent increments. So $3.25, $3.50, and $3.75. Again, just to demonstrate what a line graph looks like, suppose on September 1st, gas was pretty high then, you guys. That was like Labor Day weekend. I'm going to put it up there at about $3.55. The next week, hopefully, it's gone down a bit, so I'm going to put it down here just under $3.50. On the 15th, I'm going to really hope like crazy that it goes way down, although I don't really expect that. On the 22nd, I know those gas prices they tend to rise, you know, they jump for no specific reason, I think, and then I'm going to have it even out here. So our line graph, you draw a dot to represent what's happening on each of your time periods, but then you connect them. Line graphs are good for showing trends over time. In fact, that's exactly what they show. That's the end of our lesson today with this one note. Most software, most spreadsheet software, and all statistical software will create any of these types of graphs for you. Excel is very handy for creating very nice graphs. They look a lot better than these hand-drawn ones. Okay, that's the end of the lesson for today. We're going to ask you to get out there, do the U-Try, and we'll talk to you about this in school.